So if you remember from last week, we're working on what is the Kalam cosmological argument. Have it up on the board. But before we dive in there, as I said last week, and sort of relating all this back to Christianity, I sort of want to just give a reminder of that. In 1 Peter 3:15, it says, "Always be ready to make a defense to everyone who asks you to give an account for the hope that is in you. Yet do this with gentleness and respect." This is sort of like my motto for this class and why I sort of seek this knowledge to always sort of be ready to answer people. And as I was talking last week, we live in an increasingly secular world, as I said, and skepticism is everywhere. I mean, you can see it in the news media how much Christianity is ridiculed. And my encouragement is to not respond with anger to that. Try your best to respond with love. And, nothing pierces to the heart like love. And if you can answer people's questions, like with that love and with that kindness and with the respect, one of the biggest things is if you can just respect other people's views, that goes a long way. But so again, in talking about modernity and modern man, I want to read a quote, and this is actually from the 1900s, 1908 to be specifically. It's from G.K. Chesterton, and if you haven't read Chesterton, I really recommend. I mean, he's one of the most quotable writers, I've read. And again, this is in 1908, and I think it really applies today, and he's talking about modern man. This is what he says. "Modern man, as a politician, he will cry out that war is a waste of life, and then, as a philosopher, that all life is a waste of time. Modern man, as a pessimist, will denounce a policeman for killing a peasant, and then prove by the highest philosophical principles that the peasant ought to have killed himself. This man goes first to a political meeting where he complains that savages are treated as if they are beasts. Then he takes his hat and his umbrella and goes to a scientific meeting where he proves that they are beasts. In short, the modern man, being an infinite skeptic, is always engaged in undermining his own minds. In his book on politics, he attacks men for trampling on morality. In his book on ethics, he attacks morality for trampling on men. The modern man in revolt has become practically useless for all purposes of revolt. By rebelling against everything, he has lost his right to rebel against anything." And again, he wrote this in 1908, and yet I still think that this has even increased, with the rise of relativism and the rise of, everyone defining truth as they see it. And I'm hoping that even if you just take little bits from this class, is that it helps you to answer like that and to combat that. So with that being said, we'll get right into the argument. Remember last week, I sort of gave defenses for premise one, but let's read the argument again. Whatever begins to exist has a cause of its beginning. The universe began to exist. Therefore, the universe has a cause of its beginning. As I said before, this argument was basically refined in the 12th century by a Muslim scholar, Al-Ghazali. And going with what I just said, one of the reasons I like to use the him in this is because it gives you an in to speak to a Muslim. If you can come to a common ground with a Muslim, it sort of softens their heart, and then you can use this and then lead from this argument right to Christ. But again, we're going to go right into premise number two, the defense of this premise. The universe began to exist. Now, this might seem very common sense to everybody, but this is actually highly debated both in science and in philosophy. And I'm going to start with Al-Ghazali's defense. And again, remember, this was actually in the 1200s. And so what he talked about, I'm going to write them down, is he talked about potential infinites versus an actual infinite. Now, what you might think of an infinite is probably the potential infinite. When you think of infinity, whether it be in numbers or something that just basically has no end, it's you think you can count for infinity. You can never reach infinity. Infinity is a thing that is constantly growing. And this is sorry, my microphone is falling off. this is what is called a potential infinite. And this is like, you may have seen the lazy 8. And that's what this is called. And that's, again, how I think most people understand infinity to be. Something that is progressing towards infinity, but like never reaches infinity. It's indefinite. Now, there is this thing that is actually called an actual infinite. And this is actually signified by the Hebrew letter. I don't know if I can write this. Let's see if I can get it. Something like that, but that's called the Aleph. And that symbolizes an actual infinite. And this is something that's used in mathematics. And they will actually say that like there is the infinite set of real numbers. And that is a complete set, but it is also infinite. And so this defense of this premise has to do with these two infinites. So what Al-Ghazali said was that an actual infinite does not actually exist. It is impossible for an actual infinite number of things to exist in the real world. And like I said, mathematicians in set theory will talk about actual infinites. But again, I don't think mathematical objects are real things. Now, why does he say that an actual infinite cannot exist? And we'll get into it, but when we think about it, it's like, sort of how can an infinite number of things be set? Like, how can there be a set of infinite number of things when infinity of numbers like never ends? Yes, as John just said, it's sort of a self-contradiction. And the reason like mathematicians will use it, and this is actually called transfinite math, so the reason they're able to use this is because they set rules. They set these arbitrary rules that like, you're not allowed to subtract infinite amounts from each other. You're not allowed to add certain infinite amounts. And they'll say like, oh, see, it doesn't contradict because we have these rules. But again, these are mathematical rules that are just created to prevent contradiction. But in the real world, like, there's nothing to prevent like a contradiction from happening if you had an actual infinite number of things. So how can we use this for the premise number 2? As Al-Ghazali said, if the universe had existed for infinite past, there would be an infinite number of past days or past events. You could be infinite number of hours, infinite number of seconds, and that would be an actual infinite. And so, as I just said, like an actual infinite number of things can exist. Like, how could the past have existed for eternity? And like I said, there are these absurdities that sort of come from that. That if we had an actual infinite number of things, or we'll just stick with numbers. If we had an actual infinite number of numbers, we could subtract, let's say, all the odd numbers from this infinite set, and then we'd have all the even numbers, but yet they would both still be infinite. So even if you took all the odd numbers out of the set of infinite numbers, you'd have two infinite sets. So infinity minus infinity equals infinity. We can use the same example where, let's say, we subtract all the numbers that are greater than 3 from the set. So you have infinity, and every number greater than 3 is still infinity. So you have infinity minus infinity, but you're left with 1 and 2. So infinity minus infinity is 2. So again, you get these contradictions when you have like an actual infinite number of things. There's a mathematician named, I think his first name is David Hilbert. And he has this thing he came up with, because I think he was around again the middle 19th century when this was being developed. And he came up with this illustration. It's called Hilbert's Hotel. Now, this is sort of a fun game you can play. Like, imagine a hotel with an infinite number of rooms. So you have this huge, don't imagine a huge hotel, just imagine a hotel with an infinite number of rooms. And then imagine there's an infinite number of guests in all those rooms. So the hotel is full. There's no vacancy. And again, if actual infinites exist, you can have a hotel with infinite rooms and each room is full with a guest. Now let's say someone shows up to his hotel and they're like, oh, hey, I'm looking for a room. I need a room. And the guy who runs the hotel says, oh, okay, no problem. So what does he do? He just takes the guest in room number 1 and says, hey, you go to room number 2. The guest in room number 2, hey, you go to room number 3. And he does that on out to infinity. And even though like every room is full, there's an infinite number more rooms. And so he can just move everyone over one, even though there's an infinite number of people. So again, you get these weird, I know it's a weird thing to think about, but again, we have to say, this is what happens if you have an actual infinite number of things. And then he could do a similar thing where you could take each guest, sorry, let me start over. Let's say he takes an infinite number of new people show up. So you have a hotel full of guests, and then a new infinite number of people show up. And they say, hey, we all need a room. You might think, oh, well, the hotel is full. But no. He then takes each person and moves them into the room, double their room. So the person in room 1 moves to room 2. The person in room 2, he moves to room 4. The person in room 3, he moves to room 6. Every number, when you double it, gives you an even number. So by doing this with every person, he then frees up every odd numbered room. And then you have an infinite number of odd rooms. He moves all these people into all the odd rooms. All right, and we're just getting started. And again, like, these are mind games you can play, but if the past exists for eternity, we would have an actual infinite. And yet, these are meant to show that you can't actually have an actual infinite. Now, we can play more mind games like this. I mean, there's one that uses marbles. Say, I have an infinite number of marbles. I could then give John an infinite number of marbles because I just give him all the even marbles. Now we both have infinites. But then John could then divide his infinite number again and get another infinite number. So again, the only response to this point that an actual infinite can't exist is that someone might say, well, like, no, they use an actual infinite in modern set theory. But again, like, mathematics in this way aren't actual things. It's like when you can create your own rules to prevent contradictions, it's like a fictional world. It's almost like the world of Sherlock Holmes. Like, it's just created by someone. And math, in this transfinite math, works the same way. Like, again, the rules of this math, like, so like, you can have something that's called Aleph 0, which is Aleph null, and then you can have Aleph 1, and these could be two infinite sets. And then in transfinite math, I can say, oh, we can add these together, and we'll get, Aleph 1. You could do Aleph 2. Again, they call this transfinite arithmetic, and they're saying like, oh, they're adding infinities. Again, they're just representations. Like, it's the same as number 1 adding to number 2, like, and it's not an actual infinite. So again, I think that the defense to say like, oh, in math an actual infinite exists, like, well, it really doesn't. You can't. It's just like, it's arbitrary to me. Okay, drink of water again. Again, I know thinking about infinity is not something that's easy. And I even deny like that the mathematician is actually thinking about an infinite number of things. Even Aristotle, going all the way back, said that an actual infinity is even impossible to conceive of. Like, he doesn't even think it is like what we call, I talked about abstract objects. Like, Aristotle doesn't even think infinity is an abstract object. He thinks you can't even conceive of infinity because you're always stopping at some point, and then you have to add 1 to that point. So again, even if, I'm going to move on, even if an actual infinite existed, Al-Ghazali had an answer to this. So if we had an actual infinite, infinite number of past days, or we'll say past events in an infinite past, it's impossible to pass through an infinite. So it would be impossible to get to today if the past existed for eternity. So what this is, on my sheet, I said it's impossible to get to an infinite through successive addition. So if the past existed for eternity, like, how did we ever get to today? Because every point we go back into the past, there is an infinite previous amount of past. Good way to picture this, if you can, is imagine an infinite train of dominoes, and imagine they're falling. And again, they go back for infinity. They've been falling for infinity, so there's no starting point. No one started the dominoes falling. Then how do we ever get to a current domino to fall? If every domino that fell, there's an infinite number of dominoes before it. So again, this imagines an actual infinite number of previous days, but yet even if that were true, we could never get to today. We can think of someone like counting down. Imagine someone was counting down all the negative numbers, and 0 would represent today. So you like ran into this person and he's counting, and you like run into him and he's like -2, -1, 0. I counted down from infinity, but it doesn't work. Like, why did he stop? Why did he hit 0 today? Why didn't he hit 0 an infinite number of days ago? Because he would have had another infinite number of negative numbers to count down from. Yeah, it's frustrating. Tommy has a question.
You had mentioned in either last week or the week before that certain scientists like Carl Sagan believe that the universe always existed. So you're saying that like a guy like Carl Sagan did believe in an actual infinite then, correct?
I mean, based on what he said, I don't think he ever explored this.
Okay.
I don't think he would say like, oh, I believe in an actual infinite. But when you take what he says like, oh, the universe is all that there ever was, and it's always been here. Then if you take that and examine it philosophically like we are, we're saying, oh, so we could say to him, oh, so you believe that the universe is actually infinite in the past, and then you explain, well, this actually isn't possible.
So maybe I'm just jumping the gun because maybe you're going to dive into it. I'm wondering like what his argument would be for trying to explain how something could exist infinitely in the past. You know what I mean? Mm-hmm. But I guess, are you going to cover that? I don't.
I mean, like I said, there isn't really a response to this.
There's not.
No, what they would say is that from some of the things I read, they might just bite the bullet and they might just say, like the example of Hilbert's Hotel that I use, they might just say, well, that's actually what happens. They would say like, oh, like these weird sort of contradictions actually exist because, and again, like that doesn't really make any logical sense, but that's sort of, they would rather choose that than choose to believe that like the universe actually has a cause, and that's sort of like, what this comes down to. You're not sort of trying to convince someone that like, oh yeah, you're right, I believe this all of a sudden. No, but you're going to get people to accept things like illogically. And that's usually what people do. There are, like I said, the response to this is that people will point to this modern set theory and say that actual infinites exist based on math. And like I said, I don't think mathematical objects are real objects. And again, because when we apply them to real things like the marbles or like Hilbert's Hotel, you can show that like this doesn't make sense. Like it doesn't make logical sense that an actual infinite number of things exists. One response I did read is what a lot of people say about an infinite past is that, okay, you can't count down from infinity to get to today. However, any past day you pick is a finite number away from today, so you could always count down to today. So you could pick every point in the infinite past and count down to today. However, I don't know if you remember last week, I talked about the fallacy of composition. Now, and I said how that was misused, but in this case, they are committing a fallacy of composition. And they're saying like, just because every past day is a finite distance away from today doesn't mean that the whole past is then a finite distance away from today if we live in a universe that has an infinite past. So it's one part doesn't apply to the whole. Like I said, like, you know, you take a part of an elephant, could be light, but doesn't mean when you put them all together, the whole elephant is light. So again, I think they commit that fallacy of contradiction when they talk about this.
So you're saying there's no actual infinite?
Linda just asked me if I'm saying there's no actual infinite. I'm saying there's no actual infinite number of things. Like there can't be an infinite number of things. And if you want, I can go over these illustrations again if you want. Okay, I know this is tough, but do people sort of have a grasp of like the arguments from infinity and actual versus potential infinites? And like I said, a potential infinite, time could be potentially infinite. Like the future could go on infinitely, it could be, and will never actually reach infinity. You know that, and that's what a potential infinite is. And I think that time very much is that. But I don't think it is an actual infinite, because you can't, an infinite and a closed set don't work together. You know, you can't have it. JJ has a question.
We're saying that.
I was just going to repeat it, but.
Yeah, Tommy's making it human. We're saying that actual infinity is not real, or at least an actual infinite number of things is not real. Are we saying within the universe? Because if we believe that God has always been and always will be, I don't get how that applies. Like you're basically proving right now infinity doesn't exist, but
I'll answer your question.
Okay.
I think I know where your question is. So, in terms of God, when we talk about like God as being infinite, we're talking about a quality. Remember, this is talking about a quantity. So you have qualitative versus quantitative. God is one thing. God is not an infinite number of things. His qualities are infinite. Like God is all loving. So when we describe that quality of God, God is all knowing. So we talk about his knowledge as being infinite. But it's not an infinite number of things. Like there's not an infinite number of gods. Or in terms of my view is that, you know, God didn't exist for all, well, he's existed for all time, but before there was time, like there wasn't an infinite number of past events, you know? So before the creation of the universe, God wasn't existing in this infinite time because there was no time, you know? And God is, we talk about God as being changeless, so there wasn't like an infinite number of events going on with God, like he wasn't changing infinitely, like we talk about God being changeless, outside of time, before time began. Now, I do think that, like, you know, I don't, you know, when we talk about God as being all-powerful, his power, it's like he can do anything that is, I think, metaphysically possible. So, like, God can't do contradictions. You might have heard of, like, oh, God created a boulder so heavy he couldn't lift. Like, that's just a meaningless statement. And now, I also think that, could God create an actual infinite? Again, I think it's the same thing as that. Like, it's a metaphysical impossibility, so God, therefore, like, couldn't do it. It's not putting a hamper on God's power. It's just saying, like, you know, God can't create a contradiction. You know, he's not going to make something true and not true. So that's where I think this falls. Do you understand sort of the difference between quantity versus quality? You know, and that answered your question? That's sort of what you're asking? Okay. Yeah, I mean, that comes up a lot. And it's about, when we're talking about the infinity of God, we're talking about his qualities.
I just always think of infinity as time. So for me, it's about beginning and end, not about like numbers.
Mm-hmm.
So that's why I'm on it.
Okay, but time, like when we're talking about time as in the universe, it is an infinite number of things. It's like events, you know? And I think that, like I said, imagining God existing out of time is very hard for us, but when you talk about God being changeless, then it makes, because, you know, you can't have change without time. And so, like, if God is not changing, then, like, time is not passing. Any other questions? No?
Putting it in my head, like, God can be outside this room because he's outside of our universe. So then why can't infinity exist outside of our laws of the universe as well? like if math and time and physics are all part of our universe, then can't infinity exist in some other law? Like,
Well, it depends on, like I said, what you mean about infinity. If it's like a quantitative infinity, if it's an infinite number of things,
so what-
like it still doesn't work. Like it's something that could be moving towards infinity. Like, and I think that in terms of our Christian faith, I think that our time we will be spending with God for infinity is a potential infinite. Like it's never ending. It never reaches the terminal infinity of an actual infinite. You know, infinity with God will just be continually going on. It won't be an actual infinite. Like I think you're thinking of this, and yes, but it's just like you're getting hung up on the difference between actual versus potential. And like I said, it's a contradiction. I think John is right when John said it's a contradiction in terms, like an actual infinite. All right.
I mean, those are the people that, people just really just get caught up in that.
So Patty asked if there's people that actually believe in actual infinites.
Well, I mean, I know there are, but I mean, is there a lot of people that just?
I mean, I don't know if there's a lot of people, but I'm saying that I think that people don't tend to think of it this way when they say like, oh, the universe just has existed for past eternal. And then this is a way you present it to them. When you present the contradictions of infinity, then it sort of has to force someone to think about a universe that has existed for eternity. You know, these kind of things come up. Like I think the big one is you can't pass through an infinite. So we could never get to today if there was an infinite number of past events. Like, because I know it's hard to think about, but, you know. Okay, so I think everybody sort of has a somewhat grasp on infinity as much as it can be.
Their proof that God always was.
That's the part that's hanging me up too, because I totally get this.
We're taught when we're little, God always was and always will be. I mean, name him a metric.
Using time and numbers together.
Not
That's the hard
like,
thing.
Benjamin said that there's actual mathematic laws that would prevent actual infinites. No.
We're supposed to God that likes that.
Well, I mean, this comes down to sort of personal belief. So I'll explain it this way. I think that, yes, God always was, but time always wasn't. So, and, you know, like, so God didn't exist for an infinite number of days because there weren't days, you know. God just always was. And like I said, but, and because we talk of God being changeless, like there wasn't an infinite number of changes going on. And like God, when you're all-knowing, like we talk about God all-knowing, he's not thinking about things. Like, you know, he doesn't have to think like, oh, that's interesting. Oh, I just realized that. Oh, I just realized that. Like, because time even passes mentally. We have like these mental events. So it's like we think about something in 1 second. You know, I know these are big things and it's hard. Like, these are things that we can't conceive of. You can't conceive of a God who, like, you know, he already is all-knowing. Adam is laughing at me. Yeah. Oh, yeah. Oh, yeah. 1 + 1 does equal 2. Check.
I can understand his answer when he answers often, I am.
Yes. However, this comes down to sort of my personal preference or belief in that, like, is that once God created the universe, God then initiated a change, and then God entered into time. I think that, like, once God starts to create things, once God makes change, that simultaneously creates time, and then God also exists within time. Like, so now God is part of time. You know, he's existed outside of time, but now he is also part of time. Because, like I said, you can't have change without time, because you have two separate states. So my headset keeps falling off, and it's annoying.
It sounds good, though.
Okay.
Can we judge time by the orbit of the Earth. When the Earth turns 24 hours, everything about us is about how fast the Earth is turning. We don't know if the Earth has always turned this fast or if it turned faster. before or not. We have no idea. And when you leave the Earth and you go into space, where it's not about the Earth turning, it's about other things turning, and so time is completely irrelevant or relevant to what is it that God has determined what time is. But all we're doing is determining what time is based on how the Earth is rotating. And we don't even know if that's been constant. That's just my comment.
That's comment from Pastor Dave. But like I had brought up like mental events also. Like you can have, if you imagine that, nothing exists except your own mind. Like even your thoughts exist in a succession. Like so, even if you have no concept of time, the Earth's rotation, is that when you have a change in thought, when you're thinking about one thing and then thinking about another thing, that is also a type of time. That's like you have one event and then the next event and the next event. So it's like even when you sort of, they can argue that, like the universe was once in a physical state that was so subatomic, time didn't even like affect it. But if change had happened in that subatomic state, then time then occurred. Once you have a change of state, time changes, like whatever that measurement is. And that's why I like to emphasize that God is changeless. So that God wasn't affected by time before the universe existed.
I'm a little confused. Maybe a lot. Okay, so the universe began to exist, right? That's what we're looking at right here.
Mm-hmm. Number 2.
Al-Ghazali. All right, so that means to me, in my mind, if the universe began to exist, there was a time when it didn't exist, correct? So is that how that lines up with actual infinite? No.
I don't know.
So how does actual infinite play into the universe began to exist?
It's the defense of that. What we're saying? We're saying the universe began to exist, and our defense is we know the universe began to exist because it couldn't have existed for an actual infinite number of past days.
Okay.
So this is a defense of a beginning to the universe. Does that make sense?
Yes. Right. No.
No, he's saying that's how you defend against that.
Yes. Right. That's correct. So I think maybe I missed something, but actual infinite, I'm not sure. That's really not infinity. That's potential infinite, right?
Yeah.
Where it just goes on. But actual infinite isn't.
It's a contradiction.
Okay.
That's what I'm trying to
got
say. Okay.
All right.
Okay, I knew this would be a brain teaser. All right, so we're gonna move on from the actual potential. Wait, yeah. How long do you guys got? An actual or a potential infinite? I didn't get that joke on recording. Don't worry, it wasn't that good, listeners. Okay, so I want to move on. We're still on premise 2, and we're moving on to what's called scientific confirmations of this, the beginning of the universe. I don't want to refer to these as like arguments or necessarily defenses of the arguments, because science is something that always can change. It's observations of the universe and how our universe works, and there used to be thoughts that the world was flat, and that was like a scientific thing. So as we make more discoveries, science always changes. So you don't want to get too hung up or too like strongly into science as like a core belief, because that becomes what's called scientism. Like when you think that science is saying that science can reveal all truth. And the problem is that statement itself isn't a scientific statement. So therefore, there is an objection to that claim that science can reveal all truth. Science is about an observation. Oftentimes, you hear about like creationism versus evolution, and I'm not going to get into those two things, but an honest scientist will say that, like, well, before like the beginning of the universe, like, what was there? And if a scientist is honest, he will say that that's not a question for science. So that's like a question for philosophy and religion. And so I think the problem with the creationism versus evolution thing is that on our side is that we've tried to present creationism as a scientific argument, where it is not. You know, it's a religious and a philosophical argument. And so like these two things don't even need to be entered into the same realm. I know, yes, there are many scientists who engage in scientism and will say, you know, that, oh, well, the universe couldn't have had a cause, or, you know, at the beginning of the universe there was nothing before that. But honestly, like, honest scientists will just say, like, that's not a scientific question. Look, I'll tell you what I can observe about the universe, and then you have to look to other fields of study to answer that question. So anyway, again, into the scientific confirmation. We'll try to go through this quick and not get too deep into it, because some of this stuff can get sort of heavy and annoying and boring. Actually, this is easier than the infinity stuff, in my opinion. In 1917, Albert Einstein, he applied his general theory of relativity to the universe. His general theory of relativity I'm not going to go into, but it was basically a theory of gravity. And what he found was something that he wasn't expecting. He found that the universe was either collapsing or expanding. And now, what Einstein had assumed, and many people had assumed before this, is that the universe was uniform. It was like what's called the Euclidean plane, and sort of just like this plane with like a grid, you can imagine. And it was just like the universe was just, and imagine this is just going on in all directions. And it's all the same. And they imagine, like Newton, when Newton discovered gravity, assumed that the space was just uniform. Space was all the same, and that gravity sort of a bit larger objects affected smaller objects. So when Einstein applied his theory, he didn't expect to find that the universe was either expanding or collapsing. He didn't understand it. I know that's weird to say that Einstein didn't understand something. So then in 1920, a Russian scientist named Alexander Friedman and a Belgian scientist named Georges Lemaître discovered that, using Einstein's theory, that the universe was actually expanding. And they actually discovered this separately. You know, they weren't working together. They both came to the same discovery. And then in 1929, Edwin Hubble, who the Hubble telescope is named after, who's an American, he confirmed both Friedman and Lemaître by tirelessly looking at the night sky. He was looking at all areas of the night sky. And he discovered what you might have heard is called the red shift. Now, what the red shift is, he noticed that all the light from the stars and the distant galaxies didn't look as it should have. It had this red shift in the light. And what he realized is that the light was actually being stretched. And like the reason it was being stretched is that the universe was actually expanding. So the light was actually being stretched through space. Now, what he also confirmed, I might not draw this because it's going to be hard to draw, but and what you might think and what you've been told is that like the universe is expanding and all these galaxies are basically flying away from each other. This became known as the Big Bang Theory. But it's not like a good word for it, because you sort of think of an explosion, like there's an explosion and then all of a sudden all these space dust turn into galaxies, and then all these galaxies are expanding away from each other. Galaxies are not actually moving. They're spinning, but our galaxies are at rest in space. Actual physical space is expanding. The galaxies aren't actually moving away from each other through space. Space itself is actually expanding.
Really?
Yes. So you can sort of picture a balloon. Like, think of a balloon and imagine you have a bunch of buttons glued to the balloon, and then the balloon expands when you blow it up. This is, I mean, our universe, it's not actually like a balloon, but the buttons are staying still as the balloon is expanding. So actual physical space. What's that, JJ?
They're not moving through space.
They're not moving through space. Space is actually expanding. Yeah. So, I mean, it's a hard concept to grasp. Yeah, so I mean, I think you sort of imagine that there's this endless empty space out there and the galaxies and stars are moving through it. No. Space itself is actually expanding. So again, like the Big Bang sort of makes you think of an explosion, but it's not an explosion. There was sort of this moment of creation. I mean, they call it the singularity, and then all of a sudden things started to exist and the universe expanded. And things are getting stretched. Not that we're actually physically getting stretched, but every galaxy is actually becoming more and more isolated. We're moving away from all the other galaxies because all space itself is actually growing. Okay, so I think that one works the best.
But it's telling us moving, right? But it's still in some spot.
Yeah, but
That's on the balloon.
But outside the universe, like you're thinking of the balloon is expanding through space. Like space is not expanding through space. Like actual reality itself is expanding. That's what they discovered.
Yeah, thank you.
Like there's nothing outside the universe. So it can't be expanding into it. It's just expanding. There you go.
My dad had a 60 galaxy and that wasn't.
We got a joke. I'm not going to repeat that one. So again, what also Einstein's theory discovered, and think of the balloon, and this is we used to think gravity was a force. We thought like the Earth was actually pulling on us. What Einstein also discovered is that if you think of the balloon and the surface of the balloon being elastic, if you put something on it, like something with weight, like it would create a dimple. Things with mass actually create dimples in space. Like so the planet Earth actually creates a dimple in space, and if you put something, smaller objects would then fall into the dimple. So it's like you can think there's a good video, I should have brought it, but like, a guy has a stretchy piece of fabric and he puts like a big ball and then puts these smaller balls. They actually move towards the dimple. But they move like this. They spin down.
So wouldn't the moon be in that?
The moon would create its own dimple.
But is it in the dimple created by Earth? Yes.
But it's creating its own dimple, and that's why they're sort of spinning. And the moon is getting closer to the Earth. Every year, I think it moves about 2 inches closer to the Earth.
Can I ask a question that's irrelevant, like actual science, but just that I'm wondering, do they have any scientific explanation for why, like what reason space would be expanding? Like why?
JJ asked if there's any scientific explanation for why space is expanding. I think Tommy wants to say something about that.
I was just going to ask you about, were you going to start switching on dark energy? Because that's...
No, I mean,
The main argument right now is that dark energy is actually pushing, isn't that one of the arguments that
yeah, I mean,
expanding the universe?
they don't actually know why the universe is expanding. There is a series of what is called dark matter and dark energy that are like basically, imagine they're what's inside the balloon and they're what's pushing the balloon out. That's, again, it's unknown. There's lots of theories. Yeah. So moving on, so we have the stretching of the light, the expansion of the universe. And so again, scientific confirmation, because if something's expanding, you can trace it back to a point. In 1964, I can't really say this guy, Amo Penzia and Robert Wilson, who are both American, accidentally discovered what's called the cosmic microwave background, which is the CMB. And this is like the same energy that basically is from your microwave. And what it is it's this leftover energy in the universe. And the thing about it is that everywhere in the universe it's almost the same. There's this low level energy that they can detect that is basically the same in the universe. And what they think is that this is from a very early stage of the universe when it was like incredibly hot. So imagine you have a heat source, but then like as you move away from that heat source, the heat dissipates. But again, when you think of the expanding universe, the universe was very small, it was incredibly hot, but then as the space itself expanded, that heat gets dispersed throughout the space, and as the space ever grows, the heat actually gets colder and colder. And they use this as evidence for the expanding universe is because of the uniformity of it. You know, it's not being created by certain galaxies in different places. It's this background, basically residual heat from like the actual creation of the universe. And it's like 2.7 degrees Kelvin above absolute zero, which is incredibly cold. So it's amazing that they can even detect it. It's decreasing because the universe is expanding. That's why it's if you imagine a source of heat has to fill a space, but then that space is growing. So yeah, I lost my train of thoughts. So again, you have this expanding universe, and this is scientific confirmation of the universe beginning to exist because they can trace it back to this beginning point, and before that beginning point, they basically say that there was nothing. And they call it the singularity, but the singularity isn't actually a thing. It's just like the absence of anything. There's been a lot of, over the last, basically since Einstein came up with this, the last 100 years have been sort of trying to disprove this because scientists don't like the implications of like a beginning to the universe. There's been things called the steady state model, the oscillating universe, which is a universe that expands and contracts. Like so, they theorized we would get to a certain point and then the universe would start to contract and then get small and then expand again. The problem is there's not enough, because of what's called entropy, there's not enough energy in the universe to keep this going. Things called vacuum fluctuation models, all this stuff I'm not really going to get into because they've sort of been kind of disproven, or they're less plausible. You know, this is the Einstein's model of the universe is still considered the most plausible model. You may have heard of scientists looking for the theory of everything, or like the unified theory. What this is, they're not actually looking for a theory of everything. Einstein's theory sort of doesn't solve all the problems that needs to be resolved. Because at certain points, when you shrink the universe down, at some point it was subatomic. So that's what's quantum physics. And Einstein's laws don't apply to the subatomic field, so they're trying to discover the theory that explains how it got from that to more expand once it gets, I don't know, called post-atomic. But so, because you have these quantum laws that describe the subatomic world, and then you have these general theory laws that describe our world, and they don't mesh. So they're looking for something that unifies the two, trying to discover that. So you'll hear a lot of objections to Einstein's theory because they're like, oh, because of quantum mechanics and quantum physics, like his theory doesn't apply, or like looking for this unified theory. But it doesn't throw away Einstein's theory. It just means that it needs to be somehow resolved with this quantum realm. And the quantum realm is so new to us, and we don't really know like what we're sort of doing down there. I'll say down there. So again, if someone sort of tries to discount the Big Bang based on quantum theory or quantum mechanics, it's a misunderstanding of subatomic. When you get below the atomic level, there's all these particles, there's these fields of energy. So the quantum realm is the subatomic realm, and sort of a lot of the laws of gravity and light and stuff, the speed of light, they don't apply to these particles. So again, that's where the conflict comes in between Einstein's general relativity and the quantum mechanics. So they don't know how to unify the two. So that's what they're trying to find out how to do. And so that's where the problem comes, because if you shrink the universe down at some point in the past, it was subatomic. So it only was in the quantum realm. So they're wondering, how did it then get out of the quantum realm into our realm?
The whole universe was subatomic.
Yes. Based on this theory, the universe basically can be shrunken down to a 0 point where it was nothing. And then as it came into existence, it started on the quantum level, the subatomic level, as it was expanding very rapidly. They think that the universe itself was like, in the quantum realm, you're talking like millionths of a second. Everything is below 1 second that it was in this realm, but tons of stuff was happening. Again, you can, if you want to think of this from a Christian perspective, think of like the creation moment, because as a Christian, the philosophy we sort of describe is called creato ex nihilo, that God created all this out of nothing. So there was nothingness. So then God created all this. He created the quantum fields that then had all these quarks that then became atoms, that then became molecules, that then became universes and stars. So that's, to me, like the Big Bang, I think it's beautiful, because to me that's creation. That's when God said, "Let there be light," and there it is. And that's why, to me, in terms of JJ being sort of confused about understanding how space is expanding, it's like God's creation is just continually growing. It's continually expanding. Moving on, since in 2003, there is what was called the Borde-Guth-Vilenkin theorem. And basically, this theorem concluded, without getting into details, that any type of model of the universe that is expansionary, that no matter what type of universe you sort of want to throw out there as a model for scientists, that if it's expansionary, it must have had a beginning. So an oscillating universe that expands and contracts, at one point it had to have a beginning. Alexander Vilenkin, from this, who created this theorem, one of the members, in 2012 he said that there are no models at this time that provide a satisfactory model of a universe without a beginning. All the universes I think I miswrote this. I can't read my own writing. Oh, here it is. Continued on to say, any universe that is in a state of cosmic expansion cannot be infinite in the past. And another thing to note, that all these other models of universes presented by different scientists, they don't really hold unless they are expansionary. So even, I'm not going to get into it, but if you read up on science, you might have heard of like string theory models of universes. Those also can't sustain themselves unless they are expansionary. And as Vilenkin said in 2012, that any expansionary universe must have had a beginning. He even wrote a paper just in October confirming this. The amazing thing about Vilenkin is that he would say he's agnostic, but he's sort of an atheist. He actually rejects premise 1 of this argument. He talks about it. He thinks that the universe did have a beginning, but it was uncaused. It just sort of came into being. It's amazing what these people with these great minds can accept. Exactly. Real quick, I want to go into another totally separate scientific confirmation of this. I brought up entropy before. And there's something called the second law of thermodynamics. And basically what this says is that unless there's energy being fed into a system, that system will become increasingly disorderly. And we can view our universe as this closed system. And it is basically continually growing towards disorder. Now, I don't necessarily mean disorder in a bad way, that we have to hit a certain level of disorder, a certain level of entropy for life to be able to exist. You imagine if the beginning of the universe was just hydrogen. It was very orderly, very homogeneous, but it just stayed there. You couldn't get life out of just hydrogen. So again, a certain level of disorder allows there to be this beautiful universe we have. However, given enough time, like, and the expansion of the universe, all this energy is becoming increasingly more spread out. And eventually what will happen is called thermodynamic equilibrium, or what scientists call the heat death of the universe. Is eventually that the universe will become so spread out that energy cannot really affect anything else because it is just too far away from anything. So again, number two, if the universe had existed for eternity past, why isn't it already heat dead? You know, because given enough time, like you're moving towards entropy, moving towards this total heat death of the universe, like it should be that way. And that's sort of like just that short little scientific like confirmation of that, but the second law of thermodynamics is basically as close to like an absolute scientific fact that we can get. Like, I mean, the science behind this is more so than Einstein's theory of relativity. Entropy and thermodynamics are, there are very little doubters in this world, in the scientific world of entropy and the entropy levels. Again, going back to entropy, the model of a expanding and contracting universe that people think existed for eternity. Problem is there isn't enough energy to sustain that. As I said before, like the entropy level at this point in our universe couldn't really force what they call a big crunch. Like there's not, the energy is too spread out to force the universe to collapse back on itself. I think that's it for premise 2. Based again on our first, if you go back to our first argument, oh, we have a question. I mean, entropy is just like, oh, I didn't write down the definition. I mean, it's basically like no, entropy is a thing. Tommy, do you have the definition of it?
I'll look it up for you.
I didn't write down the definition of entropy, but
says it's a thermodynamic quantity representing the unavailability of a system's thermal energy for conversion into mechanical work, often interpreted as the degree of disorder or randomness in the system. Number 2, a lack of order of predictability, gradual decline in disorder.
So yeah, as basically what entropy is, as it's the energy level is decreasing to like force change in the universe. As time passes, as the universe expands, there's less energy to force change in the universe. So that's increase in energy, entropy. Is that because of the expansion? Yes. And because like the universe is a closed system, like we're not feeding more energy. It's so, you just think of like your car, like you need to sort of give more energy for it to keep going, It's like evaporation. Something evaporates, it cools off the system. Yes, exactly. Now, if you were here for our first argument, that was similar to this, but that was what was called the argument for an explanation of the universe. This is an argument for the cause of the universe. If someone wants to, these arguments I use them both because they sort of go hand in hand. If someone insists on an infinite universe, you can go back to the contingency argument because that argument didn't say anything about the universe having a beginning. It just said like even if the universe existed eternally, it still needs an explanation, and like that explanation would then be God. And then now if they say, and then this again is a causal argument, so they work together. I had given my sort of how we got to God last week, like why then does this lead to God? And again, real quick, I'll go over that you look at what the universe is. I mean, it's all of matter, all of time, all of space, all of energy, all of these things that we just talked about. So something to cause that must be outside of that. So it can't be like physical, It must also be transcend time and space. It has to be outside of time and space. Based on our actual infinity arguments, it must be changeless. And it also must be powerful. I mean, the cause of the universe must be incredibly powerful. I talked about it being a personal being, and that's sort of, people can get hung up on that. Why would the cause have to be personal? I read this cool, interesting little way to think of that is it's called the boiling water sort of comparison. Richard Swinburne, basically, when he talks about causes, he says there's one cause could be scientific laws combined with initial conditions can be a cause of something. But then you also have personal causes. So imagine you go into a kitchen and there's a pot of water boiling, and you say to your wife or your husband, "Oh, why is there a pot of water boiling?" And your wife or husband might say, "Oh, well, because I turned the stove on, and as the water heats up, the molecules begin to expand, and they create air bubbles in the bottom, and then the gas tries to escape," which would be the scientific and initial conditions. But your significant other could also just be like, "Oh, I'm boiling water to make pasta." Both of these are true. They're both causes. Now, when we go back to the beginning of the universe, we could say that, okay, maybe the scientific laws were always there, but there weren't the initial conditions because there was nothing at the beginning of the universe. So we didn't have any matter. So even if the scientific laws were there, there was no matter then for them to operate on. So there has to be this other type of cause to get the pot boiling. So that's it for this argument. Before I end, though, I want to sort of talk about something totally different real quick. This is like off the cuff, sort of. John, my phone's plugged in back there. Can you get it? If you're here on Sunday, Dave, I want to sort of add to something Dave said. Dave sort of spoke of some of the absolute truths of Christianity. And I wanted to like talk about one thing he brought up, just sort of expand on it. You talked about the Trinity, and the Trinity is something that is, like I said, not in the Bible, and but it's something that's sort of very hard to understand and comprehend, and I think in many ways we're not sort of meant to. But I wanted to talk about that a little bit because it sort of gives added emphasis to like the Trinity and like God both being Father, Son, and Holy Spirit, like Jesus being on earth and both worshiping his Father, but at the same time being God. And I want to read something that C.S. Lewis wrote in Mere Christianity. I'm just going to go. You know that in space you can move in three ways: to left or right, backwards or forwards, up or down. Every direction is either one of these three or compromise between them. They are called the three dimensions. Now notice this: if you're using only one dimension, you could draw only a straight line. If you're using two, you could draw a figure, say a square. And a square is made up of four straight lines. Now a step further. If you have three dimensions, you can then build what we call a solid body. Say a cube, a thing like a dice or a lump of sugar, and a cube is made up of 6 squares. Do you see the point? A world of one dimension would be a straight line. In a two-dimensional world, you'd still get straight lines, but many lines make one figure. In a three-dimensional world, you'll still get figures, but many figures make one solid body. In other words, as you advance to more real and more complicated levels, you do not leave behind the simpler things. You still have them, but they combine in new ways. In ways you could not imagine if you knew only the simple levels. Now, the Christian account of God involves just the same principle. The human level is a simple and rather empty level. On the human level, one person is one being, and any two persons are two separate beings, just as in two dimensions, say on a flat sheet of paper. One square is one figure, and any two squares are two separate figures. On the divine level, you still find personalities, but up there you might find them combined in new ways, which we, who do not live on that level, cannot imagine. In God's dimension, so to speak, you find a being who is 3 persons while remaining one being, just as a cube is 6 squares while remaining one cube. Of course, we cannot fully conceive of being like that, just as if you were to make that we perceived only 2 dimensions in space, we could never properly imagine a cube. But we can get sort of a faint notion of it. And when we do, we are then, for the first time in our lives, getting some positive idea, however faint, of something super personal. Something more than a person. It is something we could never have guessed, and yet once we have been told, one almost feels one ought to have been able to guess it because it fits so well with all the things we know already. And another thing that I want to say, sort of some of my thoughts and some of the things I read, when we compare like sort of the 3 major monotheistic religions, Islam, Judaism, and Christianity, In both Judaism and Islam, God is what is called a monad. One God, one person. And I really believe, and I think we all truly believe that, we talk about God as being love. And like we're here and we're asking, like, what was God doing before any of this was created? I mean, if God is love, like, who was he loving before we were here? Did God love himself? I mean, that sort of seems gross in a way. You know, I think it's the Trinity sort of feeds into, like, God as being love. Like, God was loving the Son was loving the Father, and the Holy Spirit. There was this community, there was this relationship, there was this individuality, but then also the oneness of the individual of God, but then this community of love. And if you've read Ravi Zacharias, he talks about this thing called there's this seeking of the human heart, this sort of unity and diversity, like where we're all individuals, but we seek like oneness with other people in our relationships. And it's sort of at the human heart to connect with people, yet retain who we are as people. I view Christianity, compared to many other religions, as one of the only ones that retains the sacredness of your individuality.